everyone, and welcome to the next episode of the journalism reaction from me, Olaf. Hello! We left off with Michikaku, and I hope this is the last part.
Guesswork. Just great. And do some research on the...
Guessing can very much be part of science. I refer to Richard Feynman's words, how do you come up with a hypothesis? Well, you guess. Also, I just went through those in a bit more detail, because there are 11, or like, sometimes you see this list, I know this list, or like this table.
difference, and you will see what we are being fed is factual, and reality is simply guesswork.
It's not fed to you as factual or reality. No one is claiming that string theory is the truth. Please, please, please look it up. No one's saying string theory is a fact. No one. No one that's informed anyway.
This chart shows the characteristics of pseudoscience versus
And I just went through all of them and even more.
actual science. Pseudoscience avoids falsifiability. It has vagueness in measurement. It takes what is unproven as false equals true. It has confirmation bias. It spends money and resources without care and has a reversed burden of proof.
None of those things apply to theoretical physics.
Sounds a lot like the Big Bang.
How?
Universe expansion, dark matter,
How?
relativity,
Can you please explain how?
space-time, black hole science, unification theory, the theory of everything.
Completely ridiculous. Clearly, Chernism has not spent any time in deeper contact or in deeper study with any science, because the things that he's accusing science here of are just ridiculous. You've never written a grant application, then you would know that they handle money with a lot of care. Getting your research to be granted money is very, 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 very difficult. For example, just because you mentioned it right now.
Supersymmetry, string theory, gravity.
Supersymmetry is not a field of science, it's like a concept.
And on the list goes.
No, I'm sorry, you're just wrong on that. Like, can you elaborate on why any of these things are pseudoscience? And I want examples, like proper examples. I want you to point out that this list or your list, I'm fine with either, and say it's unfalsifiable because this and that. I would love to hear that from you.
So next time you hear these theoretical physicists talking nonsense, make sure you remember that the evidence speaks for itself. But it's up to you to decide. Is theoretical physics pseudoscience?
Absolutely not. It's just sometimes a bit misguided by a bit of a special way of thinking in theoretical physics, and also because we have trouble doing some of the experiments that would really get theoretical physics further, because they rely on us, like on us, I say us as an experimentalist, on us to get them further, and we are struggling with a lot of the things.
I think the answer is clearly yes. Or you can continue to believe these guys and take the things they say as fact, like when we ask.
You don't need to take these things as fact. You can, even though I admit that for pretty much all of the things that you said here, that would take a couple of years of your life. But you can, in principle, check if they're correct or not.
Ask Michikaku to explain string theory.
Because we have a theory called string theory. It is fantastic. It is incredible. It has astounded the world of mathematics and physics, and now you...
He's very much overselling string theory here. If you were to ask in our faculty of physics from the university I attend, if you would ask what people think about string theory, I believe you would get 70% mostly negative response from the ones that actually say that they want to say something about it, because most people that I know would say, I don't know much about it, I'd rather not comment on that.
You can't move in the physics world without bumping into somebody who wants to talk about the 10th dimension, the 11th dimension, the
That's not my experience.
multiverse.
Might be his experience, might be under other string theorists.
Hyperspace, time travel. All the things that were once considered science fiction are now centerpiece in our understanding of the nature of everything.
Yeah,
They are centerpieces with the understanding of string theory.
it's the 11th dimension, the multiverse,
It was the 10th, by the way.
Hyperspace and time travel.
The multiverse comes out of an interpretation of quantum mechanics that is notably just an interpretation. It very much falls within the philosophical side of things. They even told us when they taught us, because they said that it might be important to at least know the more kind of basic interpretations of quantum mechanics. They even told us that this is not important and that this will not be tested or like asked at an exam or something, because it's merely a philosophical question. I personally, with science, I hold the approach shut up and calculate, which has brought me pretty far.
Things that are so clearly science fiction are now
Also, you saying that they are clearly science fiction doesn't make them clearly science fiction.
centerpiece in our understanding of reality.
I think that Michio Kaku is being very hyperbolic here, and I'd go one further and say that that's probably because he's more of a science communicator. I would be hard-pressed to find any person at our faculty, for example, who says things like that.
Or when someone asks Lawrence Krauss how the universe was created from nothing, and he gives this answer.
Let me just give a 1-minute answer because it's a long. What is remarkable is that to create stuff, it sounds like you need stuff. And to create stuff, and the conservation of energy, you would think, and this is what the argument's often used, conservation of energy means you can't start with nothing and have a universe with something. But what is amazing is when you add gravity into the mix, a miracle occurs, but a natural miracle. That gravity allows negative energy as well as positive energy configurations. Yes. And you can create...
That is correct. Within gravity, you can have... He said positive and negative. I wouldn't put it that harshly. I would say you can have some total amount of energy that has the opposite sign of some other stuff. Like there are two groups and they have an opposite sign of energy. I wouldn't ascribe either positive or negative to either. It's just a question of convention, which is positive and which is negative. The idea that Lawrence Krauss is expressing here, that if you add up all of the energies that we can think of, you roughly arrive at zero. For example, like binding energies are sometimes expressed as negative because you need to put energy in. They are kind of minus energy, if you want.
For example, two particles out of nothing. Now they have energy because of their rest mass. But if the gravitational field they're in is strong enough, the gravitational potential energy attracting them together is so strong and negative that the sum total of those two bits of energy can be precisely zero. And you can create those particles with impunity.
That is true.
In fact, that happens, we think, near black holes. And in fact, it will happen in empty space.
Yes, that's called... that's actually... Since you asked for experiments, there's an experiment behind it called the Casimir experiment, which is very nice. And I misspelled it. I'm so sorry. I would ask you to. Why is it in German? I would ask you to. You can read up on the Casimir effect, which was experimentally shown. There was an experiment. I mean, I'm sure that Sharon, you know better than all of the experimentalists because that's something that flat earthers usually do. But that's something that we can show.
And so, in fact, to create stuff, you don't need stuff. You just need nothing. And in this case, quantum mechanics.
Well,
in principle, yes.
Then you'll know that the reason these answers don't make any sense at all is because they are nothing more than pseudoscientific junk.
Says you. But, I mean, you haven't provided any evidence for that. You just said they're wrong. Honestly, I'm getting very much the feeling of, like, you saying, I don't think it's true, therefore it's not true.
Period. Of course, you're free to your own opinion. Maybe you have a different answer, but when somebody asks me, is theoretical physics actually pseudoscience? The easy answer is yes. Last thing is, I don't want to give Michio Kaku too bad of a time because as time goes on, he's actually figuring it out a little bit. This quote he gave actually makes me feel a little bit better that some of these guys do see the light at the end of the tunnel. He said, I've concluded that we are in a world made by rules created by an intelligence. Believe me, everything that we call chance today won't make sense anymore. To me, it is clear that we exist in a plan which is governed by rules that were created, shaped by a universal intelligence, and not by chance.
Sure, that's his philosophical view of things. He's absolutely free to have that. I wouldn't invoke a higher intelligence. Also, I think it's funny that you see that as a good sign, because for scientists, that's usually a bad sign, but clearly you're not a scientist. Yeah.
Imagine that. So,
okay, that seems to be the end of the video. This will also be the end of my video. With that, I thank you very much for watching. If you enjoyed this short 3-part series, I believe it was 3 parts. Yes. If you enjoyed this short 3-part series, do consider leaving a like. If you enjoyed a lot, can I maybe convince you to consider subscribing? It would be very highly appreciated indeed. And with that, I will see you with whatever I do next. I kind of want to debate someone, like not like proper debate, like with former rules, but like just have a chill talk with one of the classic flat earthers or someone else, and maybe talk about stuff there. But we'll see. With that, I will wish you a nice day or evening, and I'll see you in the next one. Goodbye.